Okay, welcome back. So let's address another variant of this case. We already covered the slide in NCC, the MRF simple, and then let's move to the two impellers with NCC. So pretty much it's the same here, but just to show you the slight differences. Here you have AMI. We're not going to touch that one. That doesn't work, but I put it just for completeness. So if we go here, first, let's see from the mesh point of view, nothing changed. The only thing that changes geometries, but we read here and see that pretty much the same. The only thing, read the pillars. So, and then if we keep reading, everything's pretty much the same. See that now we create two inner volume regions. So one with this name, volume 2, volume 1. Okay, but pretty much the steps are the same. So in line with the workflow. So all these steps pretty much the same. For a snappy, we're reading a new dictionary, create baffles. Let me open that dictionary. So we go create baffles and see that we have now rotating 1, rotating 2, and you give these names to the patches, NCC1 underscore 1, NCC2 underscore 1 and 2, okay? And these are connected to these regions that you created here. You know very well what you are doing. You know your geometry. You know your physics. Very important. So we keep reading, split baffles, do the topological splitting. Everything's okay. This is just to erase some information. Optional. And here is this step. Okay. So here, as we have two patches, we need to read this dictionary. Okay. So this will be the difference with the single body. So see that you have this one. And when you open this one, simply non-conformal 1, non-conformal 2, the names and how they are created. And that's all. Then this is a keyword for transformations. You have rotational, translational. Okay, so if you have that also, you will need to use this dictionary. So this is the only difference you see, pretty much the same. Then to set up the case, so here we're going to run only the mesh motion, not solution. But to set up, you open here and now you can add the two bodies here. So you know the names of those regions and see that to this region, sorry, to this region and to this region, apply this motion. Okay, so you know all the references and so on. And that's all. Okay. So at this point, I think we can safely run the case, run the mesh. So let me go OF12 SF run mesh. Exactly the same, nothing new. As you see, we keep adding no complexity into the cases, but everything, all the basic from tutorial 1 to 3, we keep it implementing using here and nothing changed. Okay, so let's wait for this final mesh. Okay, we have a final mesh after all the manipulations. So see that in this stack we run check mesh, everything is okay. Then here, as I mentioned, do not erase this, but you have all your patches, everything looks okay, nothing strange. Look at that, we have 3 regions. Previous case we had 2, now we have 3, and if you want to put 10, you can add it with no problem. Honestly, the maximum number of regions that I have used is 15. I don't know if there is a physical limit, but I use from one specific case 15 regions. Then here you have some check, everything perfect. I don't see any problems. Okay. Then your regions, and you can keep reading a little bit if you want. You can read all the snappyHexMesh dictionary and so on. So at this point, let's run the move mesh. Let's put the body into motion. And to recall that the motion is here and you access the two bodies with the cell zone name. And there you go. Okay, we have a solution for the mesh motion. And as you see, everything perfect, no big errors. You can check everything on your kinematics a priori. So fantastic. Okay, main flux, no errors, nothing changed. But okay, no complaints. And now let's visualize. So at this point, I already have some steps there pretty fine. I think the state two are like that one. So let's say, okay, right. Okay, there you go. So this is what we have. So orange external domain, blue on this is pink. Okay, these are the regions that are moving. So when we press play, it will be super slow. Ah, there you go. So remember, the impeller, the impeller, they are rotating together with this region, okay, that is also rotating. The rest is fixed, and there is some interpolation here. Then there are standard practices, how far or how close to the impeller or how close to this wall should you put that. So there is a lot to talk about that. Honestly, for me, a standard practice is to put everything midway. So see here that kind of these regions here is in the middle between the impeller here, the screen and the wall. And here also add a similar this on top and bottom. But yeah, that is a subject of discussion, how big, okay? But what is important is that you need to have these surfaces, you need to have them matching. That is your standard practice. But regarding the size and location, distension, that's difficult to say. So I think that's all. We have covered a lot in these 6 tutorials, and we still have one final one that hopefully we're going to put in practice everything we have learned, and some additional cases that I'm going to show you, few techniques, okay? But remember, in the meantime, if you have questions, you want to address a specific geometry meshing technique, just drop your comments in the description section or send us an email, and if we have time we might be able to address your problem or create a video. So thank you, see you next time, bye.